Goodness. All right, 1x plus 6x gives us 7x. 1y and minus 1y gives me no y. And negative 4 plus 4 gives me 0. Now, this is probably where a lot of people got confused because for some reason zeros throw you all for a loop. Okay? 0 is a number. Okay? You can divide 0 by 7. 0 divided by 7 is 0. This does not mean there is not a solution. This means the x value is 0. Can x be 0? Yeah, I mean, that's like, the middle of the graph. X is 0 anywhere on the y-axis, right? So, yes, x can absolutely be 0. So that's our solution for x. And then we just plug into either equation. So I'm going to use the first one. So x plus y equals negative 4. Well, x is 0, so 0 plus y equals negative 4, which means y equals negative 4. So my solution here is 0, negative 4. Okay, 0 is a number. You can use 0. Don't let it freak you out. All right, Dolan. Okay, so we're going to look at number 17. Notice this one, it says you may pick. So you can use whichever method you feel most comfortable with. Now, this one, though, is kind of unique, and we didn't go over any examples like this in class, so I definitely wanted to hit this one. The reason we didn't go over examples like this in class is because IXL doesn't have any like this. Okay? So, what method do you want to use? All right, I've got a graphing and I've got a substitution, so let's do both. So first, we're going to solve it using substitution. So I've got y equals that, which means I can replace y in the second equation with that, right? So instead of y equals this, I have 2x plus 1 equals 2x plus 3, right? Now from here, since I have variables on both sides, my first step should be to move them to the same side. So I'm going to subtract 2x on the right, which means I also subtract 2x on the left. But the interesting thing that happens here is both cancel out, and I end up with the statement 1 equals 3. Now, does this look familiar to anything else we've done so far this year? Do you ever remember solving an equation and getting something where it said like 1 equals 3 or something equally ridiculous and not accurate? Delson? Okay. Okay, well, not exactly. Undefined's not quite the same thing. But did you? Okay, guys, remember when we started solving equations with variables on both sides? And I said we had those two weird examples. We had the examples where it would solve down to some number equals some different number. And we said, okay, when is that true? Come on. When is that true? Never, right? 1 does not equal 3. No matter what x is, 1 is never going to equal 3. Well, there's a very simple reason why. If y equals 2x plus 1 and y equals 2x plus 3, then whatever x is, 2x here is going to be the same as 2x there, which means 2x plus 1 and 2x plus 3 are always going to be different. They're never going to be the same thing, right? So that's why this has no solution. And again, we didn't go over these specifically, but this is exactly like what we did in that section on variables on both sides. We'd have variables on both sides. And if the variables go away and you're left with a statement that has two numbers that are not equal to each other, then obviously that's never going to be true, so it has no solution. Yes?
Will there be a question like that on the test?
Very possibly.
Now.
No. Now, if we look at the same thing graphically, now this is a convenient one to graph because they're both in, right, so slope-intercept. So the first one is 2x plus 1, so my y-intercept is 1 and my slope is 2. So I'm going to rise 2, run 1. One thing I did notice when I was grading people doing the retake, guys, if you're doing a graph by hand, now you guys are mostly used to doing them on Excel, if you're doing it by hand, you have to make sure your lines are straight, okay? So if you don't have a ruler, that's fine, you know, use the, I made my lines on my answer key using the index card, okay? Anything that's straight, you know, the corner of a book, just anything that you can use to connect and make straight lines is important, okay? If you absolutely are without anything straight, then the other option is, instead of just putting 1 point and then connecting them, put extra points. If my rise is 2 and my run is 1, then I can also rise 2 more and run 1. And I can go the opposite direction and I can go down 2 and to the left 1, down 2 and the left 1. And that way I make sure that I have all the points that are actually exactly on the line are going to be there. Because this is really important. I had people who were doing things by hand and finding not the right solution because their lines were crooked. So your lines have to be straight. Okay? So there's our first line. Now our next line is 2x plus 3. So our y-intercept here is 3. And my slope is someone said it. This line right here. We graph that line. What's this line? Huh? 3 is your y-intercept. What's your slope? 2. So I'm going to rise 2, run 1. And I can also go the other direction, down 2 into the left 1, down 2 into the left 1, down 2 into the left 1, like that. So then I have this line. Oops, that didn't work right. Try again. Now, what do you notice about those two lines? They're parallel, which means if our solution to a system of linear equations is where the two linear equations intersect, and these are parallel lines which never intersect, what does that tell you about the solution to the system? There is none. It doesn't exist, right? So, by substitution, a no solution would look like this. By graphing, a no solution would look like this. Elimination is going to look pretty much like this, because like if I did multiplied one of these through by negative and then added, I'd get those would be 0 and that would be 0, and then negative 1 plus 3 would be 2, so I'd end up with 0 equals 2. So elimination and substitution are both going to end up with a number equal to some other number. The variables are going to go away, and you're going to end up with an untrue statement about numbers. And graphing is going to look like parallel lines. All right. Other questions? Brooks? 12? All right. Let's see. All right. All right, so this one, tells us to solve using substitution, which means there is no other choice. You must use substitution to solve. Now, fortunately, it does at least help us out because one of the equations already says y equals. Okay? If you don't have an equation that already has y equals something or x equals something, your first step's going to be to change one in that form. But if it already says y equals, then that means that I'm going to take that value for y. Oops. I'm still on making lines. So I'm going to take that value, and I'm going to replace this y with 2x. Hey.
I'm not going to be doing this. This is
Oh, no,
gonna be
you're fine.
interesting.
All right, so 6x plus 2 times 2x should equal 4. And then you're going to do multiplication. You don't even have to do distributive property on this one because y didn't equal 2x minus something or plus something. So it's just going to be 2 times 2x, which is 4x equals 4. And then we combine our like terms. 6 and 4 gives us 10x equals 4. Did I plug in the right thing? All right, and then divide 3 by 10. Hang on. Did I make a mistake somewhere? My math's coming out funny. Let's see.
Number 12 on our paper says 6x plus 2y equals 20.
Okay, I was thinking, I wonder if I accidentally grabbed last year's practice test. I probably did. All right, is everything else the same on it? Okay. I was like, that's the right math, but okay. Sorry, I must have grabbed the previous year's practice test, and we had decimal answers that we didn't have to have whole number answers. So, all right, let me fix that then. So everything else the same, just wrong problem. All right, so then from there, divide by 10, and we get x equals 2. Doceri. So, putting in here, x is 2, and then all you have to do is plug that in, and this equation is really easy. Y equals 2 times 2, so y would equal 4. All right.